So this will be my last segment here before I do the end of chapter problems. So here is the equation for the rocket. This is the mass of the rocket at time t, and this is dv. This is dm, the how much fuel it loses, and this is the speed of the fuel relative to the rocket as it is ejected. And we use this equation here. We can go a couple ways. If we divide both sides by dt, we will get m dv dt equals to minus u dm dt. And this is ma, force, mass times acceleration. Mass times acceleration is the force on the object, equals to negative u and then r here. This is the rate at which it loses fuel. And actually there is a no more minus sign because it's just the absolute value here. This is the thrust, the force of the thrust, equals to u times r. We can also go take this and then we divide it by m and then integrate it. So if you divide by m, you get dv is equal to negative u dm over m, and we integrate from the initial mass of the rocket to the final mass of the rocket. And here, if we start, the speed is 0 to some v final. So if you integrate this, you just get v equals to here negative u, and then the natural log of m final over m initial, and natural log with a minus sign will just flip, so you get v will equal to u times the natural log of m initial over m final. And then, so this gives you the velocity at any time. So the more fuel you burn, the more velocity you have. So when you burn all the fuel, your final mass will just be the mass of the rocket, the initial mass of the rocket, minus that of the fuel. So V maximum will be U times the natural log of the initial mass of the rocket will be the mass of the rocket, just the empty rocket, plus the mass of the fuel. And the final mass of the rocket will be just the mass of the rocket without the fuel. And that's the maximum speed. This is the speed at different intervals in time, at different times. But this is the maximum when you have burnt all the fuel. So here they say you have a rocket, this example here, you have a rocket that has a total mass. It has a total mass of 290 kilograms, 210 kilograms of which are fuel. That means the mass of the rocket itself, the empty rocket, is 80 kilograms. It says here the rocket can generate 49 kilonewtons. That's 49,000 newtons of thrust in 9 seconds. All right. So we're told that the rocket basically burns through the fuel in 9 seconds. So that's 210 kilograms of fuel burnt in 9 seconds. So that will give us the thrust here, R, which is dm dt, the absolute value of negative dm dt, which is just the rate at which you burn. So let's solve this solution. So we have R will be just this, dm dt, just absolute values. So we're burning about 210 kilograms of fuel in 9 seconds. So let's just get my calculator here to do that. And 210 over 9, 210 divided by 9 gives me 23.3. I get 23.3 kilograms per second. That's a lot of kilograms per second. It's like 50 pounds a second. And so we have that, and then we have the thrust, the force from the thrust. It's equal to 49 kilonewtons, 49,000 newtons. So to figure the maximum speed, I need U. Here, I need U. I have the masses. But how do I find U? Well, from here, I have the force of the thrust will equal to U plus R. So U will be thrust divided by R. So U will will be the force of the thrust divided by R, and that's 49,000 divided by R, which is 23.3. Let's see what we get. Times 49,000. So that's 2,100, approximately 2,100 meters per second. That means those fuels that come out of the rocket, they're coming out at 2,100 meters per second relative to the rocket. So now V maximum, V max will be U, or U is 2,100, times the natural log of, let's say, mass of the rocket plus fuel, that's 290 kilograms, divided by the mass of the rocket when it's empty. When it's empty, that's what? The fuel is 210. When it's full, it's 290. So the rocket by itself is 80 kilograms. And so this will give us what? So times the natural log of 290 over 80. And that gives 2,700, approximately 2,700 meters per second. So the rocket will be moving at 2,700 meters per second at the end of the fuel burn. So I hope you see that when they say it's not rocket science, well, rocket science is, rocket motion at least, in this simplified example, is not that difficult to analyze. And so don't be intimidated by it. Okay. I will see you next time, and we will do the end of chapter problems, at least some of them.